Here are the solutions to homework page 113. We're going to start with simple probability and do those two examples, then do independent and then dependent. So the letters to the word Fairfield are placed in a bag. What is the probability of picking an F? So as you can see, there are two F's in the word, right here in the first one, and right there. So that means my probability is going to be 2 out of, there are 9 total letters. So I'm going to put that on a number line. All probabilities are anywhere between 0, which is absolutely no chance of occurring, versus 1, which is equivalent to 100% chance. We'll put our halfway mark. And 2/9 is approximately right there, closer to 0 than the halfway point. Now for the next problem, we're going to do what is the probability of rolling an odd number on a number cube. Well, there are 3 odd numbers, 1, 3, and 5, out of 6 total sides, and of course we will simplify our fraction, which is 1/2, and that'll make it nice and easy to put it on a number line. So between no chance of happening and 100%, it is a 50-50 shot of halfway. We'll plot that point on there. Now, independent probabilities means that we are going to be taking the probability twice. So let's read the first problem. It says, the letters in the word Fairfield are placed in a bag. What's the probability of picking an F and then an I? So we will talk about the first probability, and that one is going to be the chance of getting an F, which is 1, 2 out of 9 total. And then the probability of getting an I, well, there are also 2 I's in the bag. So our two fractions are 2/9 and 2/9. So we'll multiply straight across since there's no simplification, and 2 times 2 is 4, and 9 times 9 is 81. And on our number line, between 0, 1/2, and 1. You can always change those to a decimal or a fraction to help you, but 4/9 is going to be pretty close to 0, or 4/81, excuse me. 4 out of 81 times you would get an F first and then an I second. Remember that independent probability, you're taking something out of a bag and then putting it back in. So one probability is not affected by another one. In this case, we have a spinner, and it's broken into sections that are colored red, blue, green, yellow, and orange. What's the probability of spinning once and getting a blue, and then again getting green? So the total amount's going to stay the same. There are red, blue, yellow, green, and orange. So there are 5 colors for both of our probabilities, so the total amount. The first time we want we want blue first, and there's 1 blue section, and then there's also 1 green section, and we'll multiply. And our probability is 1 out of 25 times you will get a blue first, and then you'll get green. And 1/25 is also going to be fairly close to 0. All right, so now we're going to do dependent probabilities, and those are a little bit different because the probability of one thing happening affects the other probability. So it says the letters in the word Fairfield are placed in a bag. What's the probability of picking an F and without replacing it, picking another F? So what happens is if one probability affects another one, it is reducing our total number of outcomes that could occur. So we have 2 F's out of 9 total letters. But then I don't replace one of the F's. So I keep it, which means to you that my total number of outcomes is reduced to 8, and the total number of F's in the bag is reduced to 1. Now I'm going to go ahead and simplify before I multiply. 2 goes into 2 once, and 2 goes into 8 4 times, and I'll multiply straight across. 1 times 1 is 1, 9 times 4 is 36. So 1 out of 36 is going to be down here close to 0. Now, okay, the next example is there are 2 mechanical pencils, 4 colored pencils, and 5 regular pencils in the desk. What's the probability or the chance of pulling a mechanical pencil out and then without replacing it, pulling out a colored pencil? So let's get our totals first. There are 2 mechanical plus 4 colored pencils plus 5 regular for a total of 11. And then there are, let's see, what did this say? We wanted a mechanical, which is 2. So then in our next fraction, we did not replace, which means we're reduced to 10 total writing utensils, and we want a colored pencil now, and there are still 4. So now I'll simplify before I multiply. 2 goes into 2 once, and 2 goes into 10 5 times. Now I'll multiply straight across. And 4 out of 55 times. It's right about there.